So today our topic of discussion is Introduction to Learning Rules in Neural Network. So before going into these details, I'm just giving you a very brief idea about neural networks. So if you ask me this question, that is what is a neural network, I can tell you that consider today's situation, means in today's world what we are expecting from the neural network. So considering the state of today's world and to solve the problems around us, we are trying to determine the solutions by understanding how this neural network works. And you also know this fact that it mimics the biological neurons working functionality. So our expectation is to solve some kind of real world problem using artificial neural network, right? So this is our basic objective. Now how this neural network will work, it will actually work in the same way how our human brain will work. So here we have to understand the basic foundation strategy of this neural network. So let me draw the basic architecture of a neural network. Then I will decode each and every step one by one. So if you ask me to draw a basic diagram of neural network, you will find me drawing some kind of nodes, say x1, x2 and say up to xn. So these are the nodes, and you will find me drawing some kind of weight factors along with it. And you will also find me drawing some kind of summation function, and then you find me drawing some kind of activation function. Now, whenever we are talking about this neural network architecture, without explaining the architecture, one thing you have to notice over here. Whenever I am drawing set of inputs, at the same time, you will find me drawing some kind of constant factor with these inputs. And this constant factor also will have some associated weight with it. So it will be W0. Now try to understand how this neural network can be interpreted in order to make it function to solve for real life problem. So this is a basic architecture of a neural network. So let me explain these terms one by one. So whenever I am talking about inputs of the neural network, if you ask me what is this inputs are all about, I will tell you that all the features of the model that we want to train, or the features that we are going to use to train the neural network, will be passed as an input. This statement, I think it is not clear. So I'm giving you one example. See here, we have a structure of neural network, right? It is generated using our programming language. So we will learn this code anyways. See, these are the input factors. So x1, x2, x3 and x4. Now try to understand why here we have four features and why these names are fixed for these features. So basically the first point is the input of these nodes will be the features of the data set. Now let me show you the data set so that you could understand. See, this is the data set and it is a very popular data set. It is known as Irish data set. So this Irish data set is containing three kinds of Irish flower type. The first type is known as setosa. The second type is known as versicolor. See here. And the third type is known as virginica. So we have three types of Irish flowers over here, right? Now, whenever you are visualizing the data set for the first time, the description of this data set will be recorded in another file. You can say that's a metadata part of the data set where the description is already there. So from that description, basically I'm telling you that here in this data set we have three types of flower, and here whenever we are talking about the rows in a data set, it is known as data set instances. So you will find that we will have 50, total 50 number of records for Irish Setosa type. So basically it means the person who has created this data set has collected 50 data set for Irish Setosa flower type. Why these 50 samples are collected? Because the sepal length, sepal width, petal length and petal width, these four properties of each and every Setosa flower will vary. So basically they have collected all these four features in order to describe this particular type. Similarly, they have collected 50 samples of Virginica and 50 samples of versicolor. So basically this data set is having 150 number of rows. Why 150 number of rows? Because it has already collected 50 samples of Setosa, 50 samples of versicolor and 50 samples of Virginica. I will talk about this data set later on. So here we have four features, means four attributes that can describe this particular flower types. So the values of these four attributes are given. So whenever you are designing the neural network, whatever number of features are available, it will determine the number of inputs in the neural network. So here we have four features. So we can expect that if we use some neural network in order to classify these flower types, that neural network will have four input nodes. Now, if you see this architecture, now you can understand that our objective, means what is our output, is to classify these three flowers. So from this, you can guess that in the output layer, you will have three nodes. Why three nodes? Because we have three flower types. And as an input node, you will have four inputs because we have four features in the data set. So from this discussion, we can conclude that whenever we are defining any neural network architecture, what will be the number of input and what will be the number of output nodes in the respective layers, it is totally dependent on the data set, because the features in the data set will determine the number of nodes in the input layer and the class types. Here we can say that our flower types, the class types will determine how many nodes will be there in the output layer. So this is the basic thing that you have to understand. Now see, as I am talking about input nodes, so you have to pay attention over here. So here we have set of features, right? X1, X2 up to Xn. So we can write it as in this manner, X1, X2 and up to Xn. So where n represents the total number of features and x represents the values of the features, right? So this is the basic consideration. So this is all about input nodes. Now let's talk about this weight factors. So this is the very important thing. Now if you ask me what is this weights are all about, see, we can say that initially we have to pass some random values as weight values, and these values will be automatically updated after training the neural network. So now let me correlate this weight factor with the actual neuron representation. See, we know that our brain cell will look like something like this. So this is a architecture of our brain cell, and we know that this part is known as dendrites. This part is known as nucleus, and this part is known as axon, and this part is known as synapse. Now, if you ask me this question that, okay, fine, we have understood the input factors, but why these weight factors are associated with it? See, whenever we are talking about dendrites, so this dendrites does what? Whatever information is there in the outside environment, everything is collected through this dendrites. Now try to understand this width of these dendrites are not same. So basically, if width of certain dendrite is feeble, then we can say that very less number of information will pass through this dendrite. And if we have very thick dendrite, then it can flow very large number of information. So width of these dendrites are not same. And depending on the width of these dendrites, the information flow will vary. Now, see, these dendrites are responsible for taking inputs. So here we have constructed one architecture, and this architecture is created by human being. Now here we have to also create the similar kind of activity, that some inputs will have greater weightage, means greater information, it is holding greater information, and some feature is holding less important information. So this width of this dendrite here is responsible for controlling that factor, but here this weight factor is actually doing the same thing. So here we can conclude that if weight of certain feature is high, then we can say that it is giving more importance in the classification activity. And if the weight is low, means if the weight value is low, then we can say that whatever feature we are talking about, this feature is contributing less while classifying certain data. But up to this we have understood, okay, by visualizing the value of the weight, we can determine that whether this feature, means how many importance this feature is providing while classification activity. But the important question is how we can ascertain the weight value, because initially we don't know the weight value. If you see the data set, there is only feature values are available, and how many classes will be there, it is available. But here the weight values are not available. So here you have to make a note that each input value is associated with a weight. So how they will work? So here the important fact is initially we have to pass some random values. Means we have to programmatically generate some random values, and we have to pass those random values to each and every node. So initially nobody can tell you what is the weight values, means what is this factor values. So this thing nobody can tell you. And then try to understand, after assigning the random values, whenever we start training the neural network, automatically the values of the weights will be adjusted. Now you can ask me this question, how these weights will be adjusted? See, this learning process we are going to learn today. So for that purpose, we have to learn the Perceptron learning rule. Means once we have assigned some value to the weights which are random in nature, and later on they will be automatically adjusted, and it is happening via some mathematical calculation throughout this neural network training process. So this thing we have to learn. So anyways, up to this, we have already discussed about the weights and the inputs. Now, how these inputs and weights are associated. So here we have to consider one term which is known as weighted sum, or we can say that weight sum. So what is this weighted sum? Here each input values will be first multiplied with the weight assigned to it, and the sum of all multiplied values is known as weighted sum. So let me explain this part. See, if you ask me to write the equation how these inputs and weights are associated, so we can write that weighted sum is equal to summation of all the weights that exist in this network and all the inputs that exist in the network, they will be multiplied, right? Where this summation will varies from 1 to n. Right? So this is the basic thing. So basically what we are doing whenever we are getting some input, this input is multiplied with the associated weight, say W1. Then the next input will be X2. It is multiplied with the associated weight, say W2. So this is how this process will continue. And this weighted sum means weight is multiplied and then we are adding everything is represented via this term. So this is the basic equation or basic representation how these inputs are associated with the weights. But the important thing over here is this constant factor. Why I have assigned this constant factor over here? Because it is not an input. Here I have assigned some constant values and you know that this value may be changed. So now we have to understand this constant factor, and this constant factor is known as bias. Bias in the neural network. So what we have learned so far, so we have got some idea about inputs, we have got some idea about weights, and now we are discussing the special term which is related to this architecture is bias. See, if I explain the bias term with some definitions which are available, it will not be clear to you. So basically, we will try to interpret this bias term with some basic mathematics. So let me explain this thing. Up to this, what we have discussed? We have discussed that output of the neural network, it is a function of x. What is this fx? I will tell you. But up to this, we have understood this is the basic equation that we are following for a neural network. Now, additionally here, according to our discussion, the equation will look like this. Means whenever we are calculating this thing, we are additionally attaching one bias term with it. But what is this bias is all about? So let me explain it with a simple example. Do you know what is this equation is all about? Y equal to mx plus c. Now let me explain the bias term with this simple equation. So now if this C term is missing over here, see you can relate this equation with this. So somewhat like y equal to mx plus c, right? Here I am also writing the same kind of thing. So try to understand what is this C term. C term is known as intercept. So whenever we are designing any straight line without C, it means it will be a straight line which is basically passing through the origin. It may be any straight line, but it is passing through the origin, right? But whenever we are introducing C, what happens? So basically we will get some line with some intercepts like this. So what is the C factor? The C factor is the intercept. So this is the equation for y equal to mx and this is the equation for y equal to mx plus c. Now how this intercept is helping us in order to understand bias, it's an important thing. So here we can say that if c was absent, then the graph will be formed like this. Now here we can say that in this equation, if you ask me how it is related to the equation of the neural network, I can tell you here consider this m as weight and consider this c as bias, and this is the input, we know that. Now let me write one simple mathematical thing. Say I have the first input as 1 and the weight associated with this input is say 2. And the second input is say 2 and the second weight is say 2. So according to the equation what we have learned so far, so we can calculate the output of the neural network by input into weight, right? Input into weight plus second input into weight. So it will be 1 into 2 plus 2 into 2. So it will be 6. Now try to understand. So this is the basic equation. But I have used this term bias over here. Means I am going to add some bias factor with it. Now how it is related, this thing you have to understand. Now see, the important thing is whenever we are discussing the neural network, we have already talked about multiple layers of the neural network, just like this. So here, try to understand each and every node is flowing some information from one node to another node. It is known as firing the information. But whenever a certain node is containing some information, then whether this information will be propagated or not to the next node, it will be determined by some factor, right? How it is determined? So for this problem, if you ask me this question that whether this information, what is the calculated information that we are having, it will be propagated or not, then I will tell you, whenever we are doing some mathematics of neural network, some input and weight values will be given and also a term will be given. It is known as trigger term. Trigger term means it's a threshold value. Means say if the trigger value is greater than 0, then only the neuron will fire. Otherwise the neuron will not fire. So this threshold value you can set accordingly. It may happen that if the trigger value is -1, then the neural network will fire, otherwise not. So for our problem, this is the input and weight values and say the trigger value or the threshold value is greater than 0. So if our calculated value is greater than 0, then our neuron will fire. Now try to understand. According to our calculation, we have got 6. And say we have added one constant value, that is the bias value, and say here we have set the bias value as -6. So what will happen? 6 minus 6, it is 0. So output of the neural network is 0. It means the network will not fire. So what is this bias term is all about? Depending on the bias term, we can state that whether a particular information will be propagated in the next level or not. Means due to the absence of the bias, the model will train over points passing through the origin only, which is not according to the real world scenario. So in the real world scenario, not every straight line is passing from the origin, right? We should need some kind of flexibility, right? So here introducing the bias will basically make your model flexible. Flexible in what sense? Flexible in training. So actually what is this bias is all about? Now let me explain this term with details. So bias is basically a term that we are introducing while writing the equation. Bias means, if you notice that we have passed some value 1 in the previous diagram. So here in this diagram, we have passed 1 as the bias value, right? And I'm stating that this bias value is also associated with some weight W0. Now this W0 is an element that adjusts the boundary away from origin to move the activation function left, right, top, down. So basically, in order to understand this bias, we also have to understand this activation function. But for the time being, I will explain this bias term again. Try to understand this bias term will be always associated with this equation in order to give the flexibility of the activation function of the neural network. So this is the main task of the bias. Now again, let me explain this term. What is this activation function is all about? Why I am introducing this thing? From this symbol, you can say that this activation function is a step function. So step function means it converts a numerical value 0 to 1. So that it will be very easy for us to classify a data, because whenever we are doing any classification, say we are just classifying spam email or not spam email. So we can classify them 0 and 1. So whenever we have this kind of problem, then we can select the activation function as sigmoid function, because it will convert the numerical value to 0 and 1. That is spam or not spam. So based on the type of the value we need as an output, we can change the activation function. Means instead of using this activation function, I can also use the sigmoid activation function. Right? If we are doing some kind of classification where we have values between 0 to 1. So whenever we have this kind of situation, we cannot use the step function. We have to use the sigmoid function. So basically, this sigmoid function is very much important to get the output of the neural network, right? So what we have discussed so far, try to understand. We have some input feature values, we have some weight values, and we are introducing some constant term which is known as bias value. Why this term? So initially, whenever we are designing this neural network, you will find no significance of this constant term. But try to understand, this neural network is designed for certain objective. So what is the objective of this neural network? See, I have designed this neural network for some kind of classification activity. Now, whenever we are classifying something, we may have some values between 0 and 1 only, or we have some values between 0 to 1 only. So in that case, this activation function will vary. So this bias term is actually used to control this activation function. That's why I'm stating that whenever we are passing any bias value with some associated weight value, it is basically adjusting the boundary away from the origin to move the activation function freely from left to right and top to bottom. Right? And if this bias term is missing, so we will have rigid kind of thing. That is something which is passing through the origin only. But we don't need this kind of value. We need a flexi activation function that can change depending on the classification type. So that if we need a flexible movement of the activation function between the boundaries, then we need to adjust the bias accordingly. Right? So here the point is, since we want this to be independent of the input features, means this movement will be independent of the input features, because we are concentrating on the output when we are talking about the sigmoid function. Depending on the classification, we will adjust. That's why we need this function to be independent of the input features. So that's why we are adding a constant so that we could get the particular sigmoid function that can move or that can adjust between the boundaries away from the origin. So this is the objective of the bias. So now you could understand that what is the actual formulation or what is the actual equation for writing any neural network, or how this neural network will work. So finally, how these equations will be written. It will be like weighted sum, and the final output will be calculated as summation of wi xi, where this summation is ranging from 1 to n, and we have to introduce the bias term. And here the value of the bias term is 1 for our network, and associated weight was w0. So this is the equation by which we can determine the output of our neural network that I have defined just now. So this is our network. So this term will be treated as weighted sum, and here instead of bi we know the value. What is the value? It is 1 multiplied by w0. So this is the actual equation that represents this neural network. But up to this, our final conclusion is, what should be the activation function? It depends on the type of task which are associated with the neural network. So what kind of task we can expect from a neural network? One I have already explained, that is classification. But we have another kind of tasks also, that is prediction. So disease prediction, some kind of thing. then we can also expect forecasting. Forecasting means say some kind of weather forecasting, solar irradiance forecasting. So these are the typical kind of real life application for which you can use the neural network. But whatever I have discussed so far, from here also you will find another consideration, that is what should be the architecture of the neural network. It is not fixed. Why? Because I have already explained that whenever we are designing any neural network, the number of nodes in the input layer and number of nodes in the output layer is totally dependent on the number of features and the number of classes present in the dataset. So dataset wise, the architecture of the neural network will vary, right? So this is the disadvantage of the neural network. Means without visualizing the data set, you will not be able to understand what will be the architecture of the neural network, right? So in order to design one neural network, you have to understand the data set with their detailed metadata description. And whatever neural network I'm showing over here, you can see that this is not a generalized neural network. This neural network is designed for this Irish dataset only. So this is not a generalized neural network architecture. So this is the drawback, you can say, of the neural network. But see, I have stated that what kind of classification you want to perform, depending on that we have many activation function, step function, sigmoid function, ReLU function, leaky ReLU function, so many functions are there. So next day we will first write a code for neural network where we will try different kinds of activation function, and we will see how our output of the neural network will vary. This thing we have to understand. So we will try to mathematically find out what are the significance of this activation function, and then we will try to apply this activation function for designing any neural network.